Welcome to The Explainer. Today, we're diving into something really cool. We're going to move beyond those generic AI assistants we all know and talk about building a digital twin of you. We're pulling some fantastic insights from the LLM Engineer's Handbook to explore how you can turn your own data into an AI that doesn't just think like you, but actually sounds like you too. I mean, we've all been there, haven't we? You ask an AI a question, and you get back this perfectly correct but totally bland response. It's got zero personality. It's informative, sure, but it doesn't feel human, and it definitely doesn't feel like you. And this, right here, is the exact difference we're talking about. Look at this. The generic AI gives you a dry, textbook definition of a concept like RAG, but your AI twin, it gives you an analogy. It's conversational, it explains things the way you would, and that right there is the whole goal. So, our first stop on this journey is moving beyond that generic AI. This is all about the quest for what engineers call a personalized large language model. And what we're trying to create is this, an LLM twin. You can think of it as your own personal digital copycat. The idea is simple, but honestly, it's so powerful. It's an AI that's been trained on your digital footprint, your emails, your posts, your writing, so that it reflects your unique voice, your style, and even your specific areas of expertise. It's not just another tool, it's a little reflection of you. So how in the world do you build one of these? Well, it all starts with the raw ingredients. We have to gather up what you could call your digital DNA. Because at the end of the day, an AI, and especially your twin, is only as good as the data it learns from. And that data, it can come from pretty much anywhere you've ever left a digital trail. Just think about all the stuff out there. You've got your professional voice from LinkedIn posts, your deep thoughts from blog articles or Substack, even your more casual style from social media and personal messages. And for all you tech folks and academics out there, it can even learn from your published papers or your code on GitHub. Every single piece is a part of the puzzle that makes you, well, you. Okay, so once you have all that data, it's time for the magic to happen. It's time to actually teach the model. This is the core training process, and engineers generally use two main techniques to get an LLM to learn how to be you. And it really breaks down into these two key methods. First, you have fine-tuning. This is all about personality. The AI reads all of your writing to learn how you talk, your tone, your word choice, your unique style. Then you have RAG. RAG is all about knowledge. This gives the AI an external brain, like a library of your own personal notes and facts, so it knows what to talk about. It can literally look things up from your life before it even answers. Okay, now this diagram might look a little intense, but the most important thing to see here is how much more accessible this has become. Traditionally, fine-tuning a huge model meant retraining the whole thing from scratch, a process that needed like a whole data center's worth of computing power. But these new techniques on the right, LoRA and QLoRA, they're total game changers. They basically freeze the original huge model and just train these tiny, super efficient new layers on top. This turns a job that used to require a supercomputer into something you could probably do on a high-end gaming PC. But, having a super smart twin isn't really enough. If you have to wait 30 seconds for every single reply, you're just not going to use it. And that brings us to our next big step, making the model efficient. Because, let's be honest, a fast twin is the only useful twin. And right here, this is the core engineering puzzle. You got this massive, brilliant model, but you have to figure out how to shrink it down so it can run super fast on normal hardware, all without making it dumb in the process. It's that classic trade-off between size, speed, and smarts. One of the key solutions here is a process called quantization. And honestly, the best way to get it is to think about compressing a photo. You know how you can take a huge image file and make it a smaller JPEG by reducing some of the detail? Well, quantization does the exact same thing, but for the AI model's internal numbers. It maps them to a smaller, more efficient range. And the result is a model that is dramatically smaller and way, way faster. All right, we are in the home stretch. We've trained our twin, we've made it efficient. The very last step is to actually bring it to life, to turn it from a file sitting on a computer into a real, usable product. And this is where a whole set of practices known as LLM Ops comes into play. So, a huge part of LLM Ops is what's called a CI/CD pipeline. The easiest way to think about this is like an automated factory assembly line for your AI twin. It means that every single time a developer wants to teach your twin a new trick or fix a bug, all the updates are automatically tested and rolled out safely and reliably. It's the engine that keeps your twin getting better and better over time. But just because the twin is live doesn't mean the work is done. Oh no. It has to be constantly monitored for this really interesting problem called data drift. This happens when the real world changes, right? And the stuff the AI was trained on starts to get stale. The new data coming in starts to look really different from the original data it learned from. And when that gap gets too big, the twin's performance starts to slip. That's the signal that, hey, it's time for a retrain. And this quote from the handbook, I think it just sums up why all this engineering stuff matters so much. At the end of the day, you could have the most brilliant AI in the world, but if the user experience is terrible, nobody's going to use it. Reliability, speed, and just working, that's every bit as important as how smart the AI is. So, after going through this whole process, from gathering your digital DNA all the way to deploying a finished product, it really makes you think, doesn't it? It brings up this really fun question for all of us. If you actually built your own AI twin, what would be the very first thing you'd want to teach it?